Hi everyone. In this video, we will discuss the interface segregation principle. So what does this principle say? Well, according to interface segregation principle, clients should not be forced to depend on method they do not use. Let's try to understand this with a very simple example first, and then we will do one more example to dive deep. So in this example, let's say we were modeling a planet where living things lives. So we have an interface called a living thing, which can breathe and walk. Now anything which moves and breathes, we call it a living thing. I have taken human class in this example, but let's assume that we have many like human, fish, etc. Now, what if we want to also model trees? In fact, they are also alive. So they should fall under the living things category. So what do? We go ahead and make trees implement living things and keep the walk implementation intentionally empty. So what kind of violation can you observe in this example? If we go backwards, we see a violation of Liskop's substitution principle because trees cannot be used in place of base class living thing among clients which call the walk method. Also, we see OCP violation because we would need to explicitly check for tree implementation and provide a different logic for execution. And this will happen with every other living thing implementation which has a method which is intentionally left empty because it does not belong there. And that's what ISP is about. Clients should not be forced to depend on methods they do not use. Okay, so let's move on to another example. But for this current example, which I just showed you, I am not going to give you this solution for the violation. I want you to understand the second example and use the knowledge to find the solution for this one. So I request you to come back at this example after you have understood the second one. Consider this as an exercise. So moving on to the next example, we had a requirement which started with this. We had to model doors which had the ability to open and close. So we created this door interface which had these two methods and started implementing this in the subclasses so that these two methods were there with them. So far, so good. Let's add something more to the requirements. Let's say we want to add a timed door to our application, which sounds an alarm when it is kept open for too long and then it closes automatically. What are our options? The first thought which comes to our mind is that since it is a door, we will add a timeout method in the door interface and create a timed door implementation for the same, as shown here in this picture. This fulfills our requirement, but what is wrong here? The problem is that even though wooden door and sliding door do not have any timer feature, they would need to implement the timeout method since it is part of the door interface now. And this causes the violation for interface segregation principle because it says clients should not be forced to depend on methods they do not use. So what's the best way to look for this? So the best way to look for this kind of violation is to look for this particular scenario. And that's pretty good. Now you know how it gets violated. But how do we fix it? Let's have a look. We are going to look at two different ways to solve this problem. The first one is using the adapter pattern, and the second one is using multiple inheritance. Instead of adding this timeout method in the door interface, we add it in the timed door adapter. So now timed door creates a timed door adapter which has a reference to itself. After the timed door adapter is created, what it does is it registers itself with the timer, and when the timer sees that it is open for too long, it sends the alarm signal to the timed door adapter back. And the responsibility of the timed door adapter is to notify the timed door that your timeout has finished and you have to close. By this approach, we have not modified the door interface. It still has those two previous methods which were open and close. And the timer feature has been implemented by completely adding new code and not modifying the older one. So here, the open closed principle is still not violated. And since we did not add any unusable methods, every subclass is replaceable in place of base class. So Liskov substitution principle is also not violated. And at the end, interface segregation principle is not violated because no one had to implement unusable methods. And that was the solution via adapter pattern. Let's have a look at the multiple inheritance based solution. In this approach, we will create a new interface which will have the timeout method. It's called the timer service client, and the timed door has to implement both the door and the new timer service client interface. This timer service has a reference to the timer itself and can register itself directly, and the notification can be done through the timer service client. And in this solution as well, we did not modify existing interface, so no class had to add any implementation for any unused methods. Now, let's compare the previous two solutions. The second solution is more simple than the first one. If our requirement is simple and we don't need any kind of pre or post processing for calls to the time doors, then we can directly go for this approach. In case we want to have some pre or post processing for time calls, we can choose to keep that responsibility in a separate adapter and only delegate the required calls to the timed door. It really depends on what your requirement is. And so these are the two ways which you can use to not have classes implement methods they do not use. It's time for you now to go back to the first example and think a solution for it. I'll give you a small hint. Try breaking the living thing into smaller interface. And here are some common practice which can help you think you can create good interface which don't violate ISP. The first one is have a look at your code and try to figure out clients which tend to use similar kind of methods. For these methods, if you could create an interface which all these client implements, the design will get simpler as it will allow you to group common clients together. The second one is changing interfaces. This is what we saw just in the last example we discussed. Instead of adding a new method to an existing interface, which requires a lot of different classes to change, it's a better idea to make a new class, implement a new interface, hence not touching any of the existing interfaces. So next time you're about to change an interface, make sure that you look for the violation of this principle because it might save you a lot of time. And that's all from my side on interface segregation principle, and I'll see you in the next video.